Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest test preparation and education platform. Guys, let me tell you something about today. It's a special day. In this day, we are going to complete the entire projectile motion, the entirety of projectile motion in a single shot. I mean, in this one session, we are going to cover the bits and pieces of projectile motion. And by the end of the session, you will realize that projectile motion is very easy. And guys, let me tell you, projectile motion has a lot of applications in real life, not just a heavy weightage in your exam, but also a lot of applications in your real life. You see that angry bird over there? It is like, flying in this projectile path. And this motion is called projectile motion. So it is there in your games, it is there in real life, it is there in your sports. And not only that, it's a pretty easy topic. I'll make sure you get every nook and corner, every bits and pieces of projectile motion in this single session. We'll cover every single concept from the projectile motion on an inclined plane, from the projectile motion on, from a height, or a projectile motion on a level plane. And you'll understand that this is a very easy topic. And it's an easy score of basket. Or it's an easy score of basket. So now, let me tell you something. This is the nation's first channel that is delivering content exclusively in English for your JEE preparation. So what are you waiting for? Click on that bell notification, click on that subscribe button to get timely updates. Not only that, like this video, share this video with everyone who wants to learn projectile motion and show them the beauty of projectile motion. And guys, I'll tell you a little bit about myself before we get started on the lecture. I am Murlidharan. I completed my MS in Electrical Engineering from University of Colorado Boulder. I am an IITian and I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I have filed 22+ patent applications in India, US and Canada. Guys, today I am here so that I can take you through this projectile motion journey. It's a very easy topic, guys. As and when we keep moving into this topic, you'll understand that it's a very easy topic and all it requires is those 3 basics Newton's equation of motion. That is all is involved in projectile motion. You have to resolve the components and apply this basic 3 Newton's equation of motion. And guys, I have something special for you. That is our JEE English Telegram channel. You can go onto App Store and Play Store, download this Telegram app, and you know what? Click on this, t.me JE_English, and you'll get onto a channel to get timely updates on our classes and schedule, and also our video books. It's an awesome thing, guys. You don't have to go through the hassle of coming online every day to see what is happening, but you'll get the timely notifications on your app. And guys, something more special from myself and Unacademy, that's our Unacademy Learning app. You may want to go to Play Store and App Store and download this Unacademy Learning app. And guys, you'll get special live sessions from our top-notch educators across the nation. And it's free, guys. So go ahead and download this app and you will learn more and keep learning, guys. And guys, if you're preparing for tests and if you're looking for some live quizzes and something like doubt clearing sessions with top-notch educators and your live assessment and test series, we have something called as Unacademy subscription. You may want to go and purchase this subscription if you're preparing for a test, guys. And let me tell you, we have the best-in-class education content. We have so many materials, so many education content on this Unacademy subscription platform. And if you're preparing for IIT JEE, you can get, a 24-month subscription if you're in 9th, 10th or 11th class. Else, if you're a dropout or a long term, you want to get maybe 12-month subscription that hardly costs 2,500 per month. If you're stuck in a lockdown and looking for some learning material which has around 6,000+ JEE content, we have it and you can go for 1 to 3 month subscription which hardly costs 5,000 per month. Guys, if you're looking for some coupon to get, a 10% instant discount, you can make use of Murli Live and go ahead and purchase the subscription. Alright guys, we'll get into the topic of the day, but before that we'll have a quote from a very renowned inventor Thomas Alva Edison. See guys, what did he say? Genius is 1% inspiration, 99% perspiration. So hard work determines your ability to think, hard work determines your ability to solve the problems, hard work determines your ability to understand any topic in this world. And physics guys, it's all about your perspiration, your efforts, your hard work. You got to give the time to make it happen. And remember that genius is 99% perspiration. That means every genius, every smart person that you're coming across is 99% perspiration. There is nothing known as like born genius, prodigies, very few outliers. They don't come in the normal range, or they are not the normal people. But 99% of the geniuses are about perspiration and hard work. You have to give the time and efforts, be it you are preparing for exams, be it you are hustling around to learn the concepts, be it you are preparing upfront, like in your 6th class, 7th class, you need to give that time. You need to understand the concepts and you'll crack the exam without any efforts. That's the game, guys. That's the game of the life as well. Alright guys, let's get into the topic now. And guys, this is projectile motion. You know what? Like this ball you see over here is traveling in this nice curvilinear path. This blue ball, like a green highlight that's traveling in a nice curvilinear path. That is called projectile motion. This travel is called projectile motion. Basically, what is a projectile motion? Projectile motion has some, limitations or some assumptions attached to it when we are talking about projectile motion. So projectile motion is basically a 2D motion in a plane where it is only influenced by the acceleration or the deceleration of gravity. That means in a projectile motion, a ball is projected in a nice curvilinear path, or an object is projected in a nice curvilinear path, and it is traveling in both the directions x and y, and it makes a curvilinear path. That is also very important to understand, and this object is released only under the influence of the gravity, and the object must be released at a certain angle. At a certain angle to the x or y axis to get this projectile motion. They cannot be parallel to the axes. So projectile motion is so simple. To understand projectile motion, all you need to do is first understand this concept. That it's a curvilinear motion and it is traveling in 2D plane and it is accelerated only by gravity. And it is projected at certain angle with certain initial velocity. Okay guys. Let's get into the next thing. Now, when we are talking about projectile motion, first let's try to understand a rectilinear or a straight line motion. So when we are talking about straight line motion, you see this car over here. At 5th second, it is at some x1 point. At 10th second, it is at some x2 point. At 15th second, it is at some x3 point. Whereas its coordinate or its position along y-axis is constant. What does this tell you? This object is moving in only one axis. It's moving along only one axis. In this case, it is, like x-axis, but it can be anything. A straight line motion will not necessarily maybe not move in a straight line. Sorry, I mean in one axis. It may move in, also it may change in two axes, but you can connect it with a straight line. That's a rectilinear motion. But generally in this topic, you study that a straight line motion is moving along a single line. So it may, if let's say I'm just rotating this axis, then in that case you'll see that, this car is moving along both the axes. Its, coordinates are changing in both x and y. But still you will be able to map that motion with a single line. A single line is good enough. That line will have just a slope, nothing else. It won't have a curved path. That's the key difference between a rectilinear motion and a 2D motion. So we are talking about a rectilinear straight line motion, and the next thing we'll be talking about is 2D non-linear motion or a curvilinear motion. So curvilinear motion is a type of 2D non-linear motion. So basically straight line motion is one which has its motion and its position changing with respect to time only along a straight line. And in this case, we are seeing that it is only changing along one axis. So now, what about 2D non-linear motion? In a 2D non-linear motion, if you see this object at different time instances or at different time, it is at different x and y coordinate. Even if you rotate this axis in this case, you will see that it is still in two different x and y. You may rotate it to make it such that, trying to map it in a single line, but you can't map it in a single line. That's the beauty of 2D nonlinear motion or any curvilinear motion in that case. So a 2D nonlinear motion has changing velocity along any two axes, any two given axes in a 2D plane where it is traveling, and you cannot generally map the 2D nonlinear motion either using a single axis or a single line, single straight line. I mean by single line is single straight line. See, I need, like at least 3 or 4 straight lines to map this motion. I hope this point is clear. So basically, what is like a curvilinear motion or a projectile motion? A projectile motion is nothing but a 2D motion where it is accelerated and decelerated by only gravity. I'll keep on iterating this gravity point again and again because this is the basic assumption of an projectile motion or of an ideal projectile motion. So it travels in a curvilinear path, it is accelerated and decelerated by only gravity. So a projectile motion is a curvilinear motion, which is a 2D motion. You cannot map it using a single line, single straight line. By line, I mean a single straight line. You need multiple straight lines to do it. And you see this over here, this ball always has a constant acceleration or deceleration and acceleration in this case, which is gravity. At 5th second, it is gravity. At 10th second, it is gravitational acceleration. At 15th second, it is still gravitational acceleration. Until the end of the motion. So, if you understand this point, if you understand this key point, it is really easy and becomes really easy, guys, to solve any problem in projectile motion. This is all about projectile motion. It does not need anything more. And we will be applying, some basic, Newton's equation of motion along with, some other basic assumptions are there that it is launched at a certain angle with a certain initial velocity. We'll look into it. You need not, worry about it if you're starting for the first time, and if you have already started the topic, you know it very well that what is projectile motion is. You're looking for, tips and tricks to solve it, and we are going to discuss that. Be it you don't know anything about this topic, you're new to this topic, you can solve it. Alright, guys. So how does this projectile motion vary in both x and y axis? If you carefully look at this projectile motion, so it is at some point x1, y1 at 0th second. So it is moving along both x and y axis, and at 5th second it is at some x2, y2. And similarly at the 10th second it is changing its position in both x and y axis. It is at x3, y3. It is really that simple. The position is changing in both x and y axis with respect to time. And this is the property, or this is, let's call it a special thing about projectile motion. That is all it is. And have you ever seen this projectile motion in real life? Pretty much every day. If you have gone to any parks, you are seeing those fountains, in projectile motion. Those fountains are in a projectile-like trajectory. So most of these real-life examples are like, projectile-like trajectory. Because, you're not throwing it straight up. You have this ball and just throwing it at a certain angle, and this is traveling in a projectile trajectory. And you can make use of this projectile motion in your sports, maybe in your art that you're creating. And this projectile motion has a lot of applications. For an example, the footballer over here is kicking this ball, and this ball is traveling in a nice curvilinear path in a projectile trajectory. You see that? And similarly, like a whale or a fish jumping out of, like a sea or an ocean, it is traveling in a beautiful projectile-like trajectory. So there are many real-life instances where you would come across that things or the objects are moving in a projectile trajectory. And in fact, you saw that game where the angry bird is also moving in a projectile trajectory, where you have just given it an initial velocity. That would be like an example of an ideal projectile motion. Alright, guys. So let's understand this projectile motion and the motion of projectile motion. Try to have a look at this. What is happening over here? The blue is talking about horizontal velocity, and the red component is talking about vertical velocity. What is happening over here? Carefully notice it. the momentum all along the y-axis or the momentum along the vertical directions all exhausted. And again it increases as it comes down. You see this object, like, this particle or object, this, like it has like this motion, this curvilinear motion. But what is happening? At the top, all this horizontal velocity, like the vertical velocity, as exhausted, and the horizontal velocity is constant. That arrow is indicating the magnitude of velocity. That's a key point, guys. In fact, let me tell you something. We have something interesting for you. That's an IIT JEE Advanced problem. So it says that a projectile is fired from the ground and follows a parabolic path. The speed of the projectile motion is minimum at the top and maximum at the beginning. Is it true or false? So this is the question. And guys, when I'm talking about question, keep typing it, keep commenting it. You need to do it all along with me. And you need to learn from your mistakes. That is more important. What has gone wrong? Even if you did it right, and is there something else that can be added to it? Or else, was my approach correct? You must be evaluating it continuously. If you are preparing for exams, or if you are, strengthening your foundation or fundamentals, you need to do it. Especially in physics, you have to do it. Alright. So projectile is fired from the ground and follows nice parabolic path. And the speed of the projectile is minimum at the top and maximum at the beginning. Is it correct, guys? It's true. So the answer would be true. You saw right over here. Like all of the velocity along y-axis or the vertical direction as exhausted at the top. So if you take a vector sum of x and y and take its magnitude, then you'll understand that all of the velocity is exhausted along y-axis, but along x-axis the velocity remains constant. So at the peak it is losing all of its y-axis velocity, and what is happening is the velocity is becoming minimum at the top, whereas at the beginning and the end it has the maximum possible velocity if it's a level plane projectile motion. Let's say if this question has told you it's a projectile motion from a height, maybe it's not true, because it's not necessary it has the maximum velocity at the beginning or the maximum speed at the beginning. Once it reaches the ground, like from a height, let's say it's at a height and you projected it, it reaches the ground, then it has the maximum velocity, because gravitation is acting. Gravitation is the only acceleration in projectile motion. That's an assumption. And what is happening is this gravity is pulling it harder as and when it keeps moving this level plane, like height. And guys, this is very important to understand. They're talking about level plane projectile motion, and the velocity is always minimum at the top of its path and maximum at the end. Rather, I should be saying at the end, given that it is projected from a height and there is nothing that is stopping it. And similarly, it is maximum at the beginning on a level plane projectile motion. Alright guys, this was an interesting problem. I guess you enjoyed it. Let's get into, like tearing apart this projectile motion. How do we solve problems around it? What is the basic assumptions? So there are like a couple of assumptions in projectile motion. So one already that is, the only acceleration on it is gravity. You call it acceleration or deceleration. It is decelerating the motion until the peak, and then it is accelerating the motion post the peak. And what are those two things that are given to the projectile motion initially? One is an initial velocity and an angle of launch. So guys, there is given an initial velocity and an angle of launch. So this ball is projected with certain initial velocity and angle of launch. And if you keep noticing it, you will understand that the velocity along x direction or the horizontal velocity is not changing in this projectile motion. The reason being, gravity is the only deceleration or acceleration acting in the case of projectile motion. Alright, I've told this point too many times. Maybe I'm not going to iterate it again, but by now you must have got it that we are assuming that gravity is the only deceleration or acceleration acting in the case of a projectile motion. Be it any kind of projectile motion on an inclined plane, projectile motion from a height. It's quite obvious from height it does not change much, but even on an inclined plane there is gravity. Okay? And the projectile motion, the object in a projectile motion is launched with certain initial velocity and certain angle of launch. And what would you do? You would resolve the components along y-axis and x-axis. So the initial velocity along y-axis is u sin theta, which is going to become 0 or minimum at the peak. And the initial velocity along x-axis or the horizontal direction is u cos theta, which remains constant in case of a level plane projectile motion, a non-inclined projectile motion. So it was really that simple. Now let's get into it. More of it. So have a intuitive and a careful look about this path of this projectile motion. You see this ball? This ball is traveling in a curvilinear path. Then it also forms a path. And that path is called projectile trajectory. So projectile trajectory is nothing but the path of the object that is created by the object in projectile motion, or the path of the object released in projectile motion. So this is a nice curvilinear path, and you know what? If you work around some little bit of equations, which we'll be doing it, you'll see that this projectile trajectory is in some geometric shape that you know very well. So this is entirely a geometric path, a very well-known geometric path. And that is nothing but a parabola. So in a projectile trajectory, what is happening is, if you map the points, you'll understand that it is a projectile like geometric path. Okay. Sorry, it's a parabolic path. So it's in a nice parabolic path in this projectile motion, and if you map this each point of this object in different time frames, in different instances, you will notice that this path is nothing but a parabola. And in fact, the x and y will always match this equation. If you throw this x and y in this equation, which we are going to derive, and that you'll see that it's like following that parabolic equation. And you also see that at different time instances, it is at different x1, y1, and this x1, y1, x2, y2, x3, y3 are changing in both x and y axis. Of course, you know that very well by now. And what is happening over here? At different time instances, it is at different x and y1, means it is a 2D motion. And it forms a parabolic path. Alright. So I told you, right, the entire projectile motion is all about Newton's equation of motion, or those three, equations of motion that you have studied before. One is V is equal to U plus AT, which you know very well. Like this, when this apple was falling down and he observed this gravity, then he started making all this awesome, Newton's like equations of motion. One is V is equal to U plus AT, the other one is S is equal to UT plus half AT square, and the other one is V square is equal to U square plus 2AS. Where V is the final velocity, U is the initial velocity, S is the displacement, and T is nothing but time of travel in our case. How much ever time it took to travel, or how much ever the time interval that you are taking, that is going to be T. V is final velocity, U is initial velocity, A is acceleration, T is time, the time of travel or the time of motion, and S is that displacement that you are calculating for that time frame. Okay guys, and the three equations are V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. Basics, very basics. Now what we'll do is, we'll apply that in x and y axis. Okay. For x axis, it's very simple. The velocity is, the constant. If the velocity is constant, that means Vx is equal to Ux, final velocity is equal to initial velocity, or you can just substitute, A is equal to 0 in the first equation, and Sx is equal to Uxt, again acceleration is 0, and this also yields the same thing. Vx square is equal to Ux square. The third equation also yields the same thing as the first one. Okay guys, so basically only two equations when you're talking about level plane projectile motion. One is Vx is equal to Ux, that is final velocity, and initial velocity are the same along x-axis or the horizontal direction. for a level plane projectile motion, and similarly the distance traveled or the distance traversed along the x-axis is going to be ux into t. Okay, the total time of travel or whatever you call it. What about y-axis? It is going to vary, right? So in the y-axis there is gravity, gravity and gravity. So what is going to happen? That gravity will be in the negative y direction. So you are going to basically write minus g instead of a everywhere. So it's going to be minus g. Instead of half at square, you are going to write minus half gt square. Rest is all the same. The difference is like the minus gt. In terms of equation, the difference is minus gt. Here you have this deceleration and acceleration continuously acting along y-axis, which also means that entire velocity in this journey is going to change with respect to time. Whereas along x-axis, the velocity is not changing. Okay guys. And what about these three equations? Vy is equal to uy minus gt, sy is equal to uyt minus half gt square, vy square is equal to uy square minus 2gsy, again minus. Just reminding you again and again, so that telling you that it is minus g. So you are very much worried about one and only one thing in this case, that is your coordinate axis, and you are resolving it. Now how do we derive this projectile trajectory? You simply make use of these equations to make it happen. So you see this projectile motion and it forms a trajectory, and how are we going to derive it? Simply there is this equation sy is equal to uyt minus half gt square, and then there is also this equation which says that sx is equal to uxt. You can substitute the time, which is the common one in both. See, sy is not common and uy is not common, and neither ux is common in both cases. So it's basically the time that you can substitute to get the equation. So once you substitute it, you'll understand that it is in form of a parabola. The path is in the form of the geometric shape parabola, the 2D geometric shape parabola. And what is the final equation? Sy is equal to uy is equal to sy is equal to uy into sx by ux. Sx by ux is nothing but t minus half g t square, which is again substituted by sx by ux of whole square. So really simple. Now we'll do one thing. We'll substitute this sy is equal to y and sx is equal to x and play around it. And also we'll do a thing. We will resolve this velocity components. Okay, we'll say uy is equal to u sin theta, assuming that the angle of projection theta was with x-axis, not along with y-axis. The angle of projection, the angle of launch was along x-axis. That theta we are going to resolve it. Using the theta we are going to resolve along y-axis and x-axis. Along y-axis it is going to be u sin theta, and along x-axis it is going to be u cos theta. Once we do that, you will get it in form of this equation. How does this work? You have basically made initially that sy is equal to y, sx is equal to x. That's what we have done, right? Sy is equal to y and sx is equal to x, and then we have just substituted again uy is equal to u sin theta and ux is equal to u cos theta. So y is equal to tan theta into x. Okay, theta is a constant, guys, because you have initially projected with an angle of launch. There it is done. Okay, remember this point. Only thing that is varying in this case is y and x, those different 2 points along the motion, because it's a projectile motion, right? It's a projectile motion. There you have this nice curvilinear path which is traveling, which is varying in time in both x and y axis. Okay, guys. So now this tan theta is also constant, and this minus g by 2 u squared cos square theta, which you basically get by substituting ux is equal to u cos theta. Here you have substituted both uy and ux. In this case, you have substituted both uy and ux, which becomes tan theta. Okay. and it is in the form of x minus a the whole square is equal to 4c into y minus b, which is nothing but a equation of parabola. Very simple, very simple. You may not want to remember this. You know how to do this now. Basically take up the 3 Newton's equation of motion, then apply it for each of this axes or each of this resolved components or resolved axes or resolved directions, and then what you're doing is you're trying to substitute the time component, because time is the only common thing in both, and then again what you have to do is you have to resolve this velocity component into sin theta and cos theta, u sin theta along y-axis and ux cos theta along x-axis, u cos theta along x-axis. That's all. Why have you told you about this specifically? Given any kind of projectile motion, any kind of projectile motion, this is the standardized method. This formula may be only be applicable for level plane projectile motion. If they change the axis, this is going to change. If they change the direction of the plane of projection, then also it is going to change. But the thing that does not change is these 3 Newton's equation of motion and this resolving components which you have to apply and substitute to get this trajectory. The equation of trajectory. Equation of trajectory means the equation of projectile motion path. That tells you about the positions of this ball, the position of any object in projectile motion in different time. Like in different time, what is happening to its position. The position of ball in different time is what this projectile trajectory exactly tells you. So given a value of x, you will be able to find out the value of y. It's really that simple. Okay guys, projectile trajectory is simple, projectile motion is simple, projectile on inclined plane is simple, projectile motion is simple. Physics is simple. Alright. So we derived this projectile motion equation, but we will work around a problem on projectile trajectory again in IIT JEE Advanced or IIT JEE 1997 projectile trajectory problem. Very, very simple problem. Let me tell you, there are a couple of ways of doing it. I will, take you through the easiest way to solve this problem. There is a trajectory of a projectile motion in a vertical plane. Let's read the question first. And it says that it is y is equal to ax minus bx square, where a and b are constant and x and y are varying. They are nothing but x is but horizontal, that position, and y is that vertical position of the projectile motion from time to time. It should have been time to time or point to point. The maximum height attained is what? Okay. Given to you is a different equation. Okay. But they didn't speak anything specific about it. It's an inclined, projectile motion on inclined plane. Then you are assuming it's a level plane projectile motion. Level plane means the projectile motion that we were seeing until now, the ideal projectile motion, the projectile motion that we are seeing over here. It's at the same plane, right? Same plane. So this is the normal projectile motion when they are talking in a question. Okay. So they have given us this equation y is equal to ax minus bx square. And they said that a and b are constants and x and y are varying with time. And y is that? Like the y-axis position or the vertical position or the vertical distances, and x is the horizontal position. How do we find the maximum height? One way is like you have just seen how to derive this projectile motion trajectory. You'll derive the projectile trajectory and substitute it, which can be a little complicated. This might be like for 2 marks or even like a 1 mark thing. So you may not want to spend that time. Rather, what you can do is simply differentiate the equation. Guys, keep doing it, keep commenting, keep writing down on your paper, keep working along with me. It will become easier and easier as and when you keep doing it. At least do it mentally. Something, keep practicing. So if I do dy by dx is equal to 0, I know the maximum height. Because y is nothing but the vertical distance. Okay. So what would be the answer? Any guesses, guys? Let's not even start doing the problem. Let's just do one thing. Just differentiate it in our mind. So when we do dy by dx, what do we get? A minus 2bx is equal to 0 for finding the maximum. So a minus 2bx is equal to 0, which means 2bx is equal to a, which means ax is equal to a by 2b. Substitute the a by 2b. The first one would be a squared by 2b, and the next one would be minus of b by a squared by 4b squared, and the b on the numerator and the b on the denominator will get cancelled in the second term. So it would be a squared by 4b. A squared by 2b minus a squared by 4b would yield a squared by 4b. Okay, let's have a look at the steps as well. There's nothing different than this. Else you can, the other thing that you can do is basically take out that, particular constant in the projectile motion and then substitute it. Equate it rather, equate that a and b and find out the value of maximum height using the traditional formulas. Or the simple method. So what I did is dy by dx is equal to 0. That gave me y is equal to, dy by dx is equal to 0 means a minus 2bx is equal to 0, just like what we spoke. That means x is equal to a by 2b. And now, what we did? We substituted that a by 2b in the equation. That equation, okay, this equation I mean, okay. Ax minus bx square is equal to y to find out the maximum height. So when we do that, what we get is a squared by 4b as the maximum height. Easy? Half a minute? You can do it in half a minute if you differentiate it and find out the value. And maybe even faster. Really that simple? Alright. So now we have started talking about height. You understood it well before we, even got onto this particular part of the lecture. So what is maximum height? Maximum height is the maximum vertical displacement or the maximum, y-axis distance attained by the object in projectile motion. Okay? And what is the speciality of maximum? Why does this object in projectile motion go to that maximum height? It loses all the momentum along y-axis. It is losing all the momentum along y-axis. That is the reason that it is coming back down. That is the reason there is a maxima along y. Okay. And along x-axis, the velocity will remain constant. So how do we derive this maximum height? I told you everything is all about the game of 3 Newton's equation of motion. So basically, at the maximum height, I know that the final velocity is 0. Because I told you the momentum along this y-axis is all drained out. There is no velocity along y-axis at maximum height. So I can make use of the third Newton's equation of motion, v squared is equal to u squared plus 2as, but along y-axis, because x-axis is not what I am concerned about. And the beauty is, guys, for any Newton's equation of motion, you can resolve the components and keep applying them independently. Okay? You can keep applying them independently even if you have 3 axes. There are 3 different accelerations acting along x, y, z. Then you can apply this Newton's equation of motion independently in those three axes. Okay? And what happens when we substitute v is equal to 0? It's basically u squared minus 2g h max. Because at v is equal to 0, it is h max, which is nothing but maximum height. This would become minus 2g h max. And what would be the h max? H max would be nothing but uy squared, right? This is uy squared. Okay? This is just the general equation. And in this, you have to substitute it for y-axis, along the y-axis. And then you would get that h max is equal to uy squared by 2g. What is uy? U sine theta, which is nothing but u squared sine squared theta by 2g. Very easy, isn't it? Now let's do a thing. We understood the maximum height. There is another kinematic property that we need to understand. There are 2 other kinematic properties that we need to understand. The next one would be total time of flight. We are talking about motion, then there is a time of flight. It is flying for a certain time, it is going to the peak, coming down. So in a projectile motion, there is a time of flight. So this object here has come down. So this total time is called time of flight. So the time of flight is nothing in a formal definition is the total time of flight is nothing but the time taken to complete the projectile motion. Okay, and you see over here, this object is varying both, like an x and y axis along with time, but at certain time the projectile motion has come to an end. This total time from this initial point to the final point is called total time of flight. What determines the time of flight? Again guys, there is a hint. There is a hint from the, like the maximum height that we derived. The hint is nothing but the y-axis is the thing that is constraining in a case of level plane projectile motion. In a level plane projectile motion, the y-axis velocity or the velocity along vertical direction is the one that is constraining the time of flight. Else there is always velocity along x-axis. It can keep traveling infinitely. At least in ideal projectile motion, it can keep traveling infinitely. But y-axis component is restricted. It is like decelerated or accelerated by gravity. Once it is coming down, it is being accelerated, but it has to come to the ground level and halt over there. Okay. So what would you do? What will you do for time of flight? So there is another thing that I wanted to tell you, and a simple way of doing it. Either, like what you can do is write down two equations. One equation where it is flying until height, because one thing is like v is equal to 0 over here along y-axis, and then you also know again u is equal to 0 over here, and another thing, these velocities match. In a level plane projectile motion, if only gravity is the thing that is influencing this projectile motion, these velocities along y-axis is equal in terms of magnitude, but they are in opposite direction. They are in opposite direction. Either you can do that, or there is another simple trick. You know that if the velocities are equal at this point, that means the time taken to fly from here to here is same as time taken to fly from the peak to again the ground level. The time taken to fly from the ground level to the peak is same as the time taken to fly from the peak to the ground level in a level plane projectile motion. Okay. So that also being said, the magnitude of velocity will be equal at a horizontal line joining this projectile motion path. Okay. If you take a horizontal line and if you join them, you will see that the velocities are equal in terms of magnitude, but not in terms of direction. So the velocities are not equal. Talking in terms of vectors, talking in terms of scalar, the magnitude of this speed is equal along y-axis, and even if you take x-axis component is not changing, so again it will be the same. Really simple. And why is the time taken to fly from like ground level to peak and peak to ground level is the same? Because the velocities are same in a level plane projectile motion. Okay. Even if not, you can apply those Newton's equation of motion to derive the entire thing in projectile motion. So we are going to do this simple thing, or what, really simple. What I'll do is, I know these two velocities are equal, but they are in opposite direction. Just write v is equal to u plus at. You will get u sin theta is equal to minus u sin theta minus gt. Okay, sorry, minus u sin theta is equal to u sin, because initially it was in the plus y direction. So u sin theta is equal to minus u sin theta minus gt. Okay, then you take this u sin theta on the other side and you find out the time of flight. Really simple. Okay, it's v is equal to u plus at. So it's minus u sin theta is equal to u sin theta minus gt. Guys, again, minus u sin theta is equal to u sin theta minus gt, which means you will take this on the other side and you will get that gt is equal to 2u sin theta, and t is equal to the total time to attain the same velocity was nothing but 2u sin theta by g, or else multiply it by 2 if given a level plane projectile motion. Okay. So this again along y-axis v is equal to u plus at. So finally you know that you will get it as 2uy by g. Time of flight is nothing but 2uy by g, which is nothing but 2u sin theta by g. So in the final velocity was minus u sin theta, because negative y direction, opposite direction, and u was u sin theta plus u sin theta, and this would be minus gt, where t is time of the flight. Okay guys, then what would happen? It's basically 2u sin theta by g is equal to total time of flight for a level plane ideal projectile motion. Awesome? Easy? Now let's talk about range. What is range first of all? Range sounds like a new term for one who is new to projectile motion. So what range is nothing but maximum height is the vertical displacement, range is the horizontal displacement. In this entire projectile motion, there is certain horizontal displacement due to this horizontal velocity, isn't it? So that horizontal displacement or that horizontal distance covered by this object in this projectile motion is called range. So this is the range. This x-axis or this horizontal distance is called the range. And the definition of range, time of flight and Hmax does not change even if you change the frame of reference or if you incline it. But the thing that would change is the x-axis themselves. Then you will assume that total range is different. But time of flight is the total time to travel or the total time that the object has traveled in projectile motion. And similarly, the maximum height would be that maximum height. That maximum height in y plane. If the y plane is tilted, then you will take it along that direction. Okay guys, really simple. Total time of flight is going to be the same thing. Maybe the range will change a little bit, and the same equation, the same component resolving techniques will be used to calculate any kind of projectile motion. A little bit of tricks, a little bit of here and there. That is all it is. So how do we derive this? You know the velocity along x-axis is constant. You know the time of flight 2u sin theta by g, which we just derived, and you will find out that the range is nothing but 2u sin theta into ux by g, which is nothing but 2u sin theta into u cos theta by g. Okay, that would be u squared or 2u squared sin theta cos theta by g, which is nothing but u squared sin 2 theta. 2 sin theta cos theta is equal to sin 2 theta. So u squared sin 2 theta by g. We are going to do the same thing. Simply, I would write it as, in a level plane projectile motion or in an ideal projectile motion where it is not exclusively mentioned as an inclined projectile motion, I would simply do ux into t to find out the range. T is time of flight and ux is the velocity along x direction, which is not affected by any external acceleration. Or else, write down this equation, do it along the x-axis because this is the one that we are calculating along x-axis. So you would write Sx is equal to ux into t because in this case ax is 0. Acceleration along x-axis is 0. And if you do that, you will find out that it is nothing but 2u squared sin theta cos theta by g, and 2 sin theta cos theta is written in the form of sin 2 theta. Okay. So the range would come out as u squared into sin 2 theta by g. Really simple. Really very simple. Now we will talk about something interesting about this range. This range has a very interesting property. This range is something that shows some magic in this projectile motion. If you carefully observe that sin 2 theta, you already understood that magic, or if you have already read projectile motion, you understood that logic. Okay. So what I'm going to do is I'm going to initially substitute this theta is equal to 90 minus theta. Then what would happen? Sin 2 theta is equal to sine of 2 into 90 minus theta. Does this tell you something, guys? Does this tell you something, students? Come on. You know this thing, right? Sin phi is equal to sine 180 minus phi. So in this case, what have I done? I have just substituted that phi is equal to 2 theta. Because you are dealing with 2 theta. It is a little bit of mathematical manipulation, but there is nothing in it. You can simply substitute instead of theta, 90 minus theta. And you would find out that for 90 minus theta and theta, the range is same in a level plane projectile motion. So sin 2 theta is equal to sine of 2 of 90 minus theta, which is equal to sine of 180 minus 2 theta, which is nothing but sine 2 theta. That also means The range is dependent on sine to theta in a level plane projectile motion. That also means that the range is going to be same for complementary angles. Any theta 90 minus theta in a projectile motion would have same range. So that being said, we are doing the same thing. We are just substituting it. We have done the same thing. So we have done range theta is equal to u squared sine 2 theta by g. Range is 90 minus theta is equal to u squared sine into 2 of 90 minus theta by g. The range of 90 minus theta is equal to range of theta. So the matching range for complementary angles, guys. Remember this point. It is fine if you remember this point. It's really easy. And this is just, like showing you that's, like at 15 degrees and at 75 degrees, it is having the same range. If some object, particle or a ball is projected at 15 degrees and 75 degrees, they have the same range. 60 degrees and 30 degrees or 30 degrees and 60 degrees are having the same range. 30 degrees and 60 degrees are having the same range because 60 is equal to 90 minus 30. Okay, really simple. And you are noticing something very important over here. What is that? See, initially the range was less at a lesser angle. Then the range started increasing. At certain point it saturated. It attained that maxima along x-axis. And then it comes back. That matching range is coming. So when is that maxima happening? What is that angle? Even when you do that sine 90 minus theta is equal to range of 90 minus theta, you are getting 90 minus theta is equal to theta, which is the point where you are getting sine of 90 minus theta. 90 minus theta is equal to theta. Isn't it 45 degrees? So 45 degrees is where you have that maximum range. So if you project an object on a level plane at 45 degrees, then you get the maximum range at that angle. Okay guys, really simple, really simple. And there is something interesting about taking the ratio of range and Hmax or Hmax and range, that is the maximum height by range. So you will notice that it is independent of gravitational acceleration and initial velocity. This ratio, just this mathematical ratio of range and Hmax is independent of gravity and initial velocity. So what did I do over here? Basically substituted the value. I said r is equal to u squared sine 2 theta by g. Okay. And Hmax is equal to u squared sine square theta by 2g. Okay. R is equal to u squared sine 2 theta by g and Hmax is equal to u squared sine square theta by 2g. U squared gets cancelled. U squared gets cancelled. Okay. U squared cancelled and then g cancelled. And then what remains is sine 2 theta by sine square theta by 2. This 2 will go on the numerator. So that would become 4 sine theta cos theta by sine square theta, where you would cancel out again that sine theta on the numerator and denominator, and you will find out that it is nothing but 4 cot theta or 4 by tan theta. Really simple. And let me tell you something. Okay. Now you do a thing. You take the inverse Hmax by range. You see that it is proportional to tan theta, it is proportional to theta. Because tan theta is proportional to theta. That tells you that Hmax by range is proportional to theta, means there is something known as slope proportionality. Okay. Something like slope proportionality that you have seen before. And a very easy way to, even remember these things, remember this concept or remember this particular phenomenon. And what is it telling you? Why is it happening? Because you're taking the maximum over here. They are proportional to tan theta or theta. And Hmax is the vertical displacement, maximum vertical displacement. Range is the maximum horizontal displacement. They are proportional to, the ratio of Hmax to range is proportional to tan theta and which is nothing but it is proportional to theta. Very easy. Let's do a very easy projectile trajectory IIT JEE problem. So in this case, you'll see, after learning this concept, my goodness me, this is so easy. If I was in 1997, I would have easily scored in this projectile motion problem or IIT JEE. So it says that the trajectory of an object in projectile motion is y is equal to ax minus bx square. The same problem statement as before. Okay, a and b are constants. X and y are the horizontal and vertical distances, or the horizontal and the vertical positions. And what is the angle of projection in this case? In that case, it was maximum height. We differentiated it and we simply found out. Now, either you can do one thing, take up that equation, the tan theta, that the projectile trajectory equation, equate it and find out, or else remember one simple thing. Okay, that is the slope proportionality thing. Okay, the slope proportionality thing, which is making the first order terms equal in a projectile motion, is nothing but the first constant with the first order terms. Okay, what is the first order constant of x over here? A. That means the angle of projection theta is tan inverse A. Okay. It is nothing but tan inverse A, which is very intuitive and simple, guys. So basically A is equal to tan theta. Even if you take up that equation, you understand that. Or you can apply, the basic intuition of the tan theta thing. Okay, there is always a tan theta attached to the first order term of x due to the slope proportionality thing. The second that B is creating, all that nice curvilinear part. Okay, guys, very easy, very intuitive, very conceptual, nothing complicated. So let's keep doing some more problems, guys. Keep writing it down along with me. Keep answering the questions if possible. Comment below or write it down on a paper. Keep learning this concept. These are conceptual questions which are going to shape your fundamentals and lay a great foundation for you. So there are two bodies of same mass m and they are projected at different angle, 55 degrees and 35 degrees. But with the same initial velocity u. Then which of the following is true? Okay, does this 55 degrees and 35 degrees tell you something? This 55 degrees and 35 degrees are, what is that? One, they are angle of projections of these two bodies. The other one, they are complementary angles. 90 minus 35 is equal to 55. Isn't it? And now, what is the thing that is going to be same for these two bodies when they are projected at same initial velocity u and at a complementary angle? Range. But what are those things that are going to be different? Time of flight and the height. So they will have same range but different maximum height. Okay, we should be going through, even in conceptual questions, in JEE, you should be going through pretty much every question. Every option, You should be going through pretty much every option because, there might be if it's a multiple correct answer one, there might be two options that are correct. So they will have same range and maximum height. This is wrong. Option A is wrong. They will have same range and same maximum height. This is wrong. They will have same range but different maximum height. They are correct. And the C, they will have same height but different range. Just to confuse you, it is also wrong. And then they will have different range and different maximum height. Just to confuse you. Actually, there is nothing confusing. This is totally wrong. You know that very well. The third one was to little bit confuse you. They gave these two options similar so that, in the haste of the exam, you will just, go for C. But remember this, guys, never ever get tensed during the exam. If you get tensed, you are losing, even though you know the correct answer, you are losing that question. Okay. Let's get into the next conceptual question. There are two bodies A and B of different masses M1 and M2, where M1 is greater than M2. where M1 is greater than M2, two bodies A and B, they are launched at 45 degrees. They are launched at 45 degrees with different initial velocities U1 and U2. Okay, so they are launched at same angle, but they are launched at different velocities and they have different masses. But masses do make any relevance in this question? No, masses are irrelevant in this question. They are launched at 45 degrees, which is maximum range problem. So you are not even worried about knowing the value of U1 and U2. So you know that these, now what we are going to work around is only U1 and U2. Even though you do not know the value of U1 and U2. Then which of the following are true? Range, time of flight, Hmax of A is greater than that of B. See, one more thing over here is U2 is greater than U1. Whereas the velocity of A is U1. So B is having a greater initial velocity or a larger initial velocity. That also tells you something about its range, range, maximum height and time of flight. The range, time of flight and Hmax for which one is going to be greater? The one with the more initial velocity. Because they have lot of velocity to drain along the y-axis. So that also means the range, time of flight and Hmax of B is going to be greater than that of A. Keep solving it, guys. Keep solving it. Really simple. Really simple. Let's get into the next conceptual question. There are two bodies. A very interesting problem, guys. Very interesting problem. Okay. Two bodies A and B of same masses, but with same initial velocity as well. They have same masses and same initial velocity U. They are in projectile motion. It is found that A has R by Hmax, range by Hmax ratio value greater than that of B. Then what is happening? So they have told you there are two bodies, they are projected with same initial velocity, and they have given you that it has been found that A has R by Hmax value greater than that of B. Then which of the following is true? And what are they talking about in this case? If you look at the option, they are talking about angle of launch. Angle of launch. Larger angle means they are talking about angle of launch. Okay. Here the fourth option is given as A might have same range but different angle of launch. Okay. So one thing you understood is R by Hmax is independent of G and U. The same goes for H by R, Hmax by R. They are independent of G and U. What are they dependent on? Angle of launch. So if I am talking about angle of launch, then I know this. If I am given the value of R by Hmax, I know that there is an angle of launch given to me in an indirect way. So A has a greater R by Hmax ratio. Range by Hmax ratio for A is greater means B has been launched at a greater angle. Because Hmax by R is proportional to tan theta. Okay? Hmax by R is proportional to angle of launch. Which means B has greater angle. Okay? But carefully look at the options. You already knew one of the answer. But maybe there are two correct answers. I haven't told you it's one correct option or two correct options. Okay. So A has been launched at a larger angle than that of B. This is wrong. They do not have same angle of launch because they have different R by Hmax ratio. And B has been launched at a greater angle, which is correct. And now what about this? A and B might have same range but different angle of launch. Greater or larger angle but different angle of launch. This is true. They might even have same range. Okay, the velocity is same. What if they are complementary? They might have. Okay. It's really simple. Let's get into the next one. Now this is an interesting one, guys. Come on, try to answer this thing. It's very easy. Two objects A and B of same masses M with initial velocity U are launched at different angles 60 and 30 degrees respectively. Okay, 60 and 30 degrees respectively means A is launched at 60 degrees, B is launched at 30 degrees. Okay. So now you need to find out the time of flight, because it's all talking about flew longer than, and the time of flight, to complete the flight. Okay. So it's a time of flight problem. Okay. A flew root 3 times longer than that of B, B flew root 3 times longer than that of A, and then A flew 3 times longer than that of B, and A and B take same time to complete the flight. Okay, there are 4 options given to you which are talking about time of flight. And what are they talking about? Like the time of flight in terms of comparing both the A and B. And now you know this 60 and 30 degrees angle are complementary. Okay, 60 and 30 degrees angle are complementary. But don't confuse it. Simply even apply the formula or think about the concept. They are covering the same range. They have been launched at different angles. What is happening? One goes to more height, the one with larger angle goes to more height and comes back down. So it is going to fly longer. But that does not quantitatively tell you the answer. So you might want to work around this proportionality thing, where it says time of flight is nothing but proportional to y-axis component velocity, which is nothing but u sine theta. So it's ratio of sine theta, nothing else. If you want to find out the comparison between time of flight, it is ratio of sine theta. And what is sine 60? Root 3 by 2. What is sine 30? 1 by 2. So, which one flew longer? A flew longer, A flew more time, A flew more height. And the ratio of time of flight is root 3, and A flew root 3 times longer than that of B. A flew root 3 times longer than that of B, because sine 60 by sine 30. 2u sine theta by g is time of flight. And in this case, all you have to remember is time of flight is proportional to y-axis velocity component. Okay guys. Now we'll talk about a special case of projectile motion. Really interesting case of projectile motion. In this time, what we are going to do is, we are not going to do a level plane projectile motion. Now I have this ball. I am projecting it from certain height. And what I am doing is, I am only giving it the velocity along x-axis, velocity along horizontal direction. And this ball will still follow a projectile motion, because they have the leverage to travel the y-axis, along the y-axis, because it's at an height. So this is the the special case. In this case, what is happening? There is only initial velocity along x direction, and this ball has only initial velocity along x direction, and it goes down and reaches the ground, and it completes the height edge. Very easy, very easy, easier than before, because in this case all you need to do is even forget one of these kinematic results that we derived before. What would be that kinematic result that we have to forget? We already know one thing. We know that there is no travel along y-axis, and this height is h. This height of the building or the height of the elevation is h from the ground level. Now, what is the thing not given to you? Time of flight and the range. So what would be the first thing that you would calculate to calculate the range in this case? Time of flight. Time of flight is something that you can calculate to make life easy. And it has to travel h distance with initial 0 y-axis velocity. Which means you have to simply apply S is equal to u by t minus half gt square. Okay. And Sy would be minus h, guys. Carefully note it. Sy would be minus h. Why minus h? Because you are assuming the origin to be this. And even if not, the displacement is in the negative y direction. Because you are taking minus g, displacement should also be minus h. So that would give me the time of flight as under root of 2h by g, because h is this total y-axis displacement. G, you take it on this other side, it's basically 2h by G is equal to under root of 2h by G is equal to time of flight T squared is equal to 2h by G. Now you know the time of flight. What would you do for the range? Really easy, really intuitive, really simple. You know the time of flight. Now the range is nothing but multiplying the x-axis velocity component with time of flight. Okay, in this entire time the x-axis component or the x-axis velocity is not perturbed. Okay, and you know the time of flight it takes to come down. So what would you do? Simply multiply them. In this case, you don't have to resolve it because initially it is given as u. So you simply multiply u into time of flight, which would be nothing but u into under root 2h by g, where h is the height of the elevation and u is the initial velocity only given along x-axis. Now let's do a thing. Like I'm a little bit crazy. I don't want to just, push it with, horizontal velocity. I want to project it from this height. I want to project it like how I did it in the level plane projectile motion, but from a height. Let's do that thing and see what happens. See guys, now you are thinking, like maybe the problem is, little bit different. Maybe it is, little bit maybe complicated. But no guys, only the things are tough as long as you don't know them. Students, remember this thing. The things are only tough as long as you don't know them. Now you know everything, how to solve a projectile motion. How to solve given any kind of problem in projectile motion. Just projectile motion problem is given to you, you will kill it. So now what we are going to do? We are going to do a very simple thing for this case. We are going to divide it into two kind of motion, or let's say two kind of like travel the path into two parts. One would be the level plane, because what it was the level plane thing first, and then let it drop and then see what is going to happen. Now in this case there would be a maximum height. Don't we have a maximum height in this case? Yes, we do have a maximum height in this case. Okay, but we will do a thing first. Write down the initial conditions. We know things are only tough as long as we don't know them, but we know all the initial conditions that is required to derive this kinematic results. So one would be, this thing, the velocity along x-axis not changing, vx is equal to ux is equal to u cos theta, and there is no acceleration along x-axis, which is saying that ax is equal to 0, and uy is equal to u sin theta, the initial y-axis velocity. The initial y-axis velocity is u sin theta. Okay, and what is the acceleration in y-axis direction? Minus g, and this sy should have been minus h. Okay, sy is minus h. Okay, now easy. Time of flight we know for the level plane projectile motion. If I projected it, like an initial velocity u and at an angle theta, that is nothing but 2u sin theta by g. But which part of the motion is this? Only the projectile motion until it comes to the same, horizontal level. Sorry, same vertical level. Only until it comes to the same vertical level. Okay. Now it is coming to the same vertical level before going down. So until then, the time would be 2u sin theta by g. Okay. Now we need to calculate the time for the rest of the motion, the time of flight for the rest of the motion. The rest of the motion is the one that is going from that level to the ground level. From this level it is going to the ground level. That is what we need to calculate. Okay guys, really simple. So how would we do that? One condition that one thing very well. It has come to the same, no other acceleration. Only gravity is the negative acceleration, and that is that like deceleration till it reaches peak and acceleration beyond that peak. Now what you need to do? You need to make use of the standard things, the standard Newton's equation of motion to calculate the rest of the time of the flight. The rest of the time of the flight would only involve the same thing, but in this case the y-axis velocity is in the opposite direction of the same magnitude. It is of the same magnitude as the initial velocity along y-axis, but in the opposite direction. Okay, initially what would I do little differently is, make use of, I know there are like two unknowns. I'll make use of two equations to calculate it. Okay, one thing I don't know is the final velocity, but I know the velocity when it is at that level plane thing. So it's going to be u squared sine squared theta, basically saying that uy is equal to u squared sine squared theta, where it was minus u sine theta, but on squaring it becomes u squared sine squared theta. Okay, so basically I've taken the third Newton's equation of motion. Vy squared is equal to uy squared minus 2g sy, or minus 2g minus h. Okay, and you know one thing, the other thing, that is it has to now complete that height h. It has come to this level, now it has to complete this height h along y-axis. So you do it as minus h, and then you would get that the final velocity along y-axis is mathematically it's plus or minus underscore of plus or minus under root u squared sine squared theta plus 2gh. Basically this equation, taking root of this equation, nothing else, Vy final. So mathematically it is plus or minus. And what about it? What about the direction? Direction is negative. Direction is negative. The final velocity is in the negative y direction. So it would be minus under root u squared sine squared theta plus 2gh. Really simple, guys. Now I know the final velocity. See, I couldn't have made use of the second equation maybe in that case to find out the time of flight, because you can do it, but it would be like solving more of a quadratic equation. But the simpler way is to find out the Vy final, the final velocity when it is reaching the ground, and then substituting it in that initial equation, the first equation of motion along y-axis, which is nothing but v is equal to u plus at. And do remember the sign convention. If you make a little bit mistake around the sign convention, just you forget this, minus sign, it will go wrong. So Vy final is equal to minus under root of u square sine square theta plus 2gh. That is what we derived. We are going to substitute this minus the minus under root u squared sine square theta plus 2gh in the first Newton's equation of motion. Okay, Vy is equal to uy minus gt. Okay, and uy in this cases we are talking about the rest of the motion once it has reached that level plane in the vertical direction. So that would be minus of under root u square sine square theta plus 2gh minus equal to minus u sine theta minus gt. This is standard, minus gt is standard, and in this case we are finding only the time of flight for rest of that motion. Okay, so gt is equal to minus u sine theta minus, if I'm taking this g the other side, it will become positive, gt at the other side, and similarly if I take this vy the other side, the magnitude will become positive. So it would be minus u sine theta plus of under root u squared sine square theta plus 2gh. Okay, so the time of flight for the rest of the motion is t minus t1. I'm just taking it as t minus t1 to tell you that that t1 has been subtracted from the total t, which is time of flight. The t1 is that initial time of flight for it to reach that level, for a level plane projectile motion, or for it to reach that same level plane. So that would be minus u of sine theta plus under root u squared sine square theta plus 2gh by g. Okay, now what do I need to do? Add both of these times. Add the both part of this times for this, two part of this motion. Okay, to get the total time of flight. So what I'm going to do? I'm going to add 2u sine theta by g plus of the one that we found earlier, that is t minus t1, which is going to give me t is equal to u sine theta plus of under root u squared sine square theta plus 2gh by g. Have you carefully noticed the, if you change this sign convention, things are going to go wrong. So be careful with the sign convention. Remember the sign convention. Okay. Remember the sign convention. You know this 3 Newton's equation of motion. Resolve the components and work around the problem. That is projectile motion all about. Now let's find out the range. Range is simple, guys. Range is very simple. What would you do? Very easy thing. Very easy thing. Range in this case is going to be this entire thing. This entire x-axis distance or this entire, horizontal displacement. So this entire thing. Okay. Never mind, it's a little bit curvy, but it has to be that, straight line along x-axis or parallel to x-axis. Now, how do you do it? Time of flight is known. You know that the velocity along x-axis in a level plane, in a non-inclined projectile motion is not changing. Even in an inclined plane motion is not changing, but we are, rotating the axes and working around the problem. But let's come to that problem later. Let's come to that concept later. Let's complete this one. So basically multiply the time of flight into, the u cos theta. You basically multiply the time of flight into u cos theta. Okay. That would give me u cos theta into u sin theta plus of under root u squared sin theta, because this is the one that we just derived. Okay. So that would give me the range. Really simple, guys. Now for maximum height, very simple. Very simple. So I hope you understood the range concept. It's ux into time of flight that we just found out, which is nothing but u cos theta into the value, the entire equation that we found. U sin theta plus of under root u square sin square theta plus 2gh by g. Now talking about height, very simple. What is it? Keep thinking. In this case, when I'm talking about h max and taking this coordinate axis over here, or talking about absolute maximum height from ground level, that is going to be you have to add this height to the h max of this projectile, level plane projectile. And what is the h max of level plane projectile, guys? What equation you are going to make use of to derive that? By now I'm guessing you must have got the entire thing. But anyway, what equation you are going to make use of to derive that? You would say that, okay, at the maximum height v is equal to 0. The final velocity along y-axis direction is 0. That also means 0 is equal to u squared sin square theta minus of 2gh minus h max minus h in this case. Okay, h max minus h, because h max is this total height. H max in this case is this total height. Okay. So we did only that simple thing. We know this, maximum height for the level plane projectile motion, u squared sin square theta by 2g, and we have added both this height. Awesome, right? Easy, very easy. Be it any kind of projectile motion, it's very easy. We'll now deal with a little bit different concept. Since we said, one shot projectile motion, we are going to complete every single concept in projectile motion. Okay. Now let's look at the other concept. But before that, let me give you a step-by-step method or a step-by-step strategy to solve any problem in projectile motion. Any problem that involves only projectile motion can be solved using this strategy. Point number 1. Resolve the components along the direction. Be it in any reference plane, be it inclined plane projectile motion, be it anything. Apply the sign convention. Understand the sign convention. Practice around the sign convention and apply the sign convention. Identify the relevant Newton's equation of motion. This is actually something that is applicable for most of the 2D, kinematic motion. If you apply the strategy, you will get the answers for most of the 2D equations of motion. So what are those 3 things that you have to remember while solving the problem? Resolve the components in x and y direction, be it for any reference plane. Apply the sign convention. Identify the relevant Newton's equation of motion. Okay, this is applicable for pretty much any kinematics 2D motion, like that involves Newton's equation of motion. Okay. And remember this thing, this is the most important thing, solving any problem that is, it is easy. Any problem is easy. You have to get into your mind that the problem is easy. Nothing is difficult. But be mindful of the time. But set in your mind that the problem is easy and nothing is difficult. That will boost your confidence. That will boost your approach. That will, like remind all your memory. That will get your memory back, and everything will happen on its own. Okay, it will relax your mind and you will be able to do it faster. Alright guys, now let's do a problem. This problem is about level plane projectile motion only. It's not about inclined plane projectile motion. We haven't covered that concept yet. We'll cover this concept, but before that we'll have a look at a very interesting problem. So it's about basketball projectile problem. I'm naming it specifically basketball projectile problem, because basketball is one such sport where this projectile trajectory has to be perfect. Because it has to, it is just that basket that I have to score inside. If I don't, if I give a longer, more velocity, or even sometimes, let's say, I'm not just delivering momentum, even a bit of force, then in that case, things mess up. I have to make sure when I'm, scoring the basket from a distance that this, velocity is such that it is able to get into that basket. But when we keep moving to this problem, we'll understand this awesomeness of basketball. So a basketball player plans to score by projecting a ball such that she or he wants the ball to cross a wall barrier and score a basket. So there is the wall barrier. It's a practice session for that basketball player. So there is a wall barrier. Now that player wants to project that basketball such that it has to score the basket. The player jumps. So the player is jumping until this height. Okay. The player jumps such that the ball is projected exactly from the height of the wall. Okay. The ball is projected such that it is at exactly the height of the ball. So the y-axis is at exactly the height of the wall. The horizontal distance between the wall and the basket is 10 meters and that of the player and the wall is 10 meters. So they also said that, the distance between the wall and the ball and the wall and the basket is 10 meters. Now, it is found that the ball was also launched at certain angle, pi by 12. Which is nothing but 180 by 12, which is nothing but 15 degrees. The player was able to transfer 80% of the momentum. The player was able to transfer 80% of the momentum to the ball in the direction of launch. What should be the velocity of the player to score the basket? Okay. So what is happening in this problem? There is a distance between the ball and the wall and the wall and the basket. And now a player is projecting it from the height of the wall and it's like a level plane motion only. There is no difference in it. So what is happening is he's projecting it from the height of the wall, at the height of the wall, exactly at the height of the wall and the basket. And there is a distance given between the wall and the basket, which is nothing but 10 meters, and the wall and the basketball, which is again 10 meters. And the ball was projected at pi by 12, 15 degrees. And guys, how much momentum was transferred by the player? 80% of the momentum was transferred by the player. What should be the velocity of the player during the launch so that they can score the basket? Easy. And weight of the player is given to us. Always note this given point. Some people do make this mistake. I often do that. I don't notice the given point. Weight of the player is 100 Newton. Weight of the player is 100 Newton and mass of the ball is 1 kg. Take G is equal to 10 meter per second square. They are asking us to take the value of gravitation as 10 meter per second square. Really easy, guys. Really easy. What is the thing that you're getting in the mind? The first thing that is given to you, some kinematic result is given to you in this case. Something is given to you. Okay. What is that is given to you? Range is given to you. Range is given to you. You know that the range should be 20 meters. Okay. The range should be 20 meters. Okay, guys. And given that the momentum is 80% transferred to the ball and the mass of the ball is 1 kg, weight of the player is 100 newtons and gravitational acceleration is said to be taken as 10 meter per second square and the angle is 15 degrees. And what we need to find out? The initial velocity or the momentum of the player during the launch. If you find out the initial velocity of the basketball, you'll come to know. Okay, it's a little mix of problem, but expect some kind of problem like this. So it is given to you. I mean, everything is given to you, and it is given to you that you should be working around the range. So you basically write down the equation for range, or even from your memory, or just apply the Newton's equation of motion. You'd get that the range is equal to that the range is equal to u squared sine 2 theta by g. And what you need to do now, find out the u of the ball. In this case, it's u of the ball, initial velocity of the ball, initial velocity of the basketball. So sine 2 theta, it was 15 degrees, sine 2 theta would become sine 30, sine 30 is half, range is 20 meters, g is 10, and that would become 20 into 20. It's basically 20 into 20. Okay, guys. Basically 20 range is equal to u squared, the unknown u of the ball, initial velocity of the ball, sine 30 by 10. So that would be 20 is equal to u squared by 20. And u would become 20 meters per second. You will find that the initial velocity of the ball is 20 meters per second. Now, they told us something, 80% of the momentum is transferred. That itself tells you that the momentum is also involved in this problem. Okay, you need to apply that trick. So what would you do? You would apply the momentum transfer, momentum conservation thing or the momentum transfer condition. Really simple. Now what would you do? 0.8, 80% of the momentum was transferred. Remember this, guys. 80% of the momentum was transferred. Okay, and this 80% of the momentum is transferred to the ball, so that you will calculate, the total momentum of the ball, which is going to be 1 kg into 20 meters per second. That would yield 20 kg meter per second. The momentum of the player transferred would be 25 kg meter per second. Because you take this 0.8 to the denominator on the other side. Okay, that would give me 25 kg meter per second as the momentum of the player. Basically, I equated the momentum. I conserved the momentum. Okay. Now there is a little bit pitfall that is given to you so that you don't notice it and you apply it at the end of the day. Boom, there you go. The problem goes wrong. What is that? That's 100 newtons as the weight. Because in a colloquial language and daily language, you're talking about weight as just the mass. But here the weight is given specifically as 100 newtons, means they're talking about the total gravitational pull along with the total gravitational pull. So that is going to be weight is equal to 100 newtons. M is mass of the player. Okay, mass of the player is M. Is equal to 100 newtons is equal to mg. They have told us to take g as 10. That means mass of the player would be 10 kgs. Weight of the player is 100 newtons. Mass of the player would be 10 kgs. Now you know the momentum. That is 25 kg meter per second. And you know the mass of the player, 10 kgs. simply the velocity of the player would have been 2.5 meters per second. Really simple, guys. Basketball is one of those examples in sports where you need to, understand projectile motion really well, even in your subconscious, so that you are able to score the basket. Alright, we got through this, all this level plane projectile motion. We are going to get into something more interesting, that is inclined plane projectile motion. This is far more interesting than what we saw before. This is where you can imagine yourself in the situation. This is one where you can imagine yourself in the situation. Think about yourself, standing at the bottom of the hill and then throwing the ball. Think about, a situation where you're standing at the bottom of the hill and throwing the ball. And this hill is an inclined plane. Nothing but an inclined plane. If you're throwing this ball from the bottom of the inclined plane, what would happen? See, if you put that, hill thing in your mind, things would become very easy. Especially the technique that we are going to adopt, it will become very easy. And it's also pretty much true, right? If you're standing on a hill, or if you're, standing at the bottom of the hill or the top of the hill, there is something that you're experiencing that you're not experiencing on a level plane. What is that? What is that, guys? What is that? In your horizontal in your horizontal direction, there is a gravitational pull, either accelerating your motion or decelerating your motion. And when I'm talking about from the bottom of the inclined plane, that I mean is the gravity is going to pull me down. Okay, guys. Really critical. Understand this point. Think about yourself standing on the hill while you're solving any problem for, projectile motion on an inclined plane. So also there is another terminology when you're calling about projectile motion from the bottom, that is known as projectile motion up the plane, because the motion is up the plane, isn't it? The motion is up the plane, so you call this kind of projectile motion where you're projecting it from the bottom of the inclined plane as up the plane. Okay, guys. Now how do we solve this problem? Same strategy. The same strategy is what we are going to make use of. Just the axes are rotated, right? This is y-axis in this case. This is x-axis. This is rotated to this due to this angle phi, which is nothing but inclination of the inclined plane or the angle of that inclined plane. Again, we are projecting it with angle theta. Okay. So now what would you do? Simple. Resolve the components of gravity first. Okay. And how are you going to resolve the components of gravity? Based on the inclination of the inclined plane. Based on the inclination of the inclined plane, you are going to resolve the components of the gravity. So see, this gravity is always along y-axis. Irrespective of anything, it is along absolute y-axis. Since the y-axis has rotated, you are also going to resolve the components of gravity. Okay. So this way the gravity is acting. If I am going to resolve it along x-axis, which is nothing but this direction, then it is going to be minus g sine theta. And along y-axis, it is going to be minus g cos theta. Okay, guys. Along x-axis, along this inclined plane x-axis, the gravity is minus g sine theta. And along y-axis, it is minus g cos theta. How did I get this minus g sine phi? Sorry guys, it is phi. So it is g phi. Okay. G sine phi and minus g cos phi. Okay. So along x-axis, it is in the negative direction of x-axis. When you are projecting it from the bottom of the inclined plane or up the inclined plane, it is minus g sine phi. Okay. And in the y-axis, it is minus y-axis direction, which is nothing but minus g sine phi, where phi is the inclination of the inclined plane. Remember this point, guys. Phi is the inclination of the inclined plane. So when I am talking about inclination of the inclined plane, how am I going to resolve this gravity component? I mean, mathematically, how am I going to do it? I know it is along absolute y-axis. The gravity is along absolute y-axis. I draw this triangle simply. Okay, I'll simply draw this triangle and you'll see that this is 90 minus phi. If the inclination of the inclined plane is phi, then this is 90 minus phi and this would be phi itself. Okay, this is going to be phi itself. And this is going to be minus g cos phi and this is going to be minus g sin phi. Okay, because positive x-axis is in this direction along the motion. Okay, now you understood this point. The next thing we should be resolving is along the angle of launch theta. So you will be resolving components along theta. Guys, keep writing it down and keep learning. So uy would be u sin theta, ux would be u cos theta, the usual thing. Okay, because we are talking about theta along, with the inclined plane. So ux would be u cos theta and uy would be u sin theta. Okay, this being said, now how do we work around this problem? Same thing. You know the Newton's equation of motion. Now you need to apply this Newton's equation of motion and make it happen. Really simple. Before that, I've just kept it in straight line because I just want to understand. I've just created some hypothetical gravities in this case. One gravity that is decelerating my x-axis direction motion, and that is nothing but minus g sin phi, and one that is decelerating my y-axis direction or decelerating and accelerating my y-axis direction motion, that is minus g cos phi. Okay, I kept it in the straight line for I just can't tilt my head all the time, so it looks very easy. So what happens now, guys? Now what happens? You're going to apply the same equations to get the same answers. Not the same answers, to get the answers. Same equation, same approach to get the answers. Really simple. So now the first thing is time of flight as usual. The easiest one is time of flight in this case. You have to apply the equation Vy is equal to Uy plus Ayt, which is the first Newton's equation of motion. And you substitute u sin theta minus dt cos phi is equal to 0. Why minus g cos phi? Because minus y-axis. That makes time of flight as t is equal to u sin theta by g cos phi, where theta is the angle of launch with respect to inclined plane and phi is the inclination of the inclined plane, or the slope or the angle of that inclined plane. So, but this is for half. What about the rest of the half? Into 2? Still I can do into 2 because along the y it's g cos minus g cos phi instead of minus g. Earlier it was minus g, now it's again minus g cos phi. Very similar situation. So if you see the time it takes to go from the the inclined plane to the maximum height along the inclined plane and coming down would be same, from the peak to the inclined plane, and from the inclined plane to the peak it would be the same. Only along y-axis. Along x-axis the scenario is going to change because we introduced a new deceleration. Okay guys. So that being said, I'll tell you something interesting about this as well. See, one way, if you don't want to resolve the components right away in the exam, or if you don't want to remember it, one simple thing you can do is notice this thing, they are of opposite, trigonometric expressions. So if along x-axis it is u cos theta, then the deceleration is minus g sin phi. And if it is u sin theta along y-axis, it is minus g cos phi. Okay guys, so cos theta, sin phi. Sin theta, cos phi. So the negative acceleration along y-axis is minus g cos phi. Easy? Don't do that. Resolve it. Sometimes they will add both the angles and give you as alpha. But just a small way to remember it. So next thing would be h max. Again easy. Again very easy. Where the velocity along that rotated y-axis becomes 0. Okay. At some point, if it is traveling like this in a projectile motion, and taking this projectile trajectory, that means at some point the y-axis component is becoming 0. Sorry guys. So this y-axis component would be becoming 0. Okay. That would be this point. So how do we calculate this? Again, Newton's equation of motion comes to our relief. Really easy. So v square is equal to u square plus 2a is the same thing, but along y-axis. Now again you substitute g as minus g cos phi. Okay, and you would get that 0 is equal to u squared sin squared theta minus of 2h max g cos phi. So that would tell me that h max is equal to u squared sin squared theta by 2g cos phi. So you saw until now what we have just basically done for time of flight and h maxes. We have just replaced them with g is equal to g cos phi. But what about the range? Would you do the same thing for the range? Even though there is an like a deceleration along x-axis, would that yield any result? Would that yield any result if I do not consider this minus g sin phi? That would lead me to a wrong solution. Simply, you need to do one thing. Okay. In this case, if I am talking about range, it is this range along the inclined plane. This range that is drawn in this white line. Okay. This range along this inclined plane is called the range in an inclined plane problem, unless and until explicitly said that you want to find the x-axis where the x-axis is not rotated, okay, where this x and y-axis is not rotated, then the scenario would change. So it's the total distance traversed by the object along the plane. That's the range on an inclined plane. And which equation would you make use of? Come on guys, think about it. Earlier what did we do? We just substituted that a is equal to 0. And which equation did we make use of? S is equal to ut plus half at square. So we did the same thing. We did Sx is equal to ux is equal to plus of half axt square. But in this case, ax is not 0, ax is minus g sin phi. So you'll find out that range is nothing but u cos theta into total time of flight. We found out the time of flight. Okay, minus of half g sin phi t squared. Again, t is total time of flight. So if you substitute the time of flight, which is nothing but 2u sin theta by g cos phi, you would come to know that it becomes u cos theta into 2u sin theta by g cos phi minus half g sin phi into 2u sin theta by g cos phi whole square. Okay, this is whole square. This would become 4 after you open up the square, but this half would cancel out and make it 2. Okay. Now I can take some terms out as common. This is just some mathematical manipulation. If you are given an absolute value, like if you are given the numerical values of theta, phi, then what you would simply do is just don't try to derive this entire thing. Or if you remember the final formula, well and good, just do it. And if you don't remember it, just substitute the numerical values. So what would happen in this case? In this case, what I'm doing is I'm taking out u squared common, because I have a u squared over here. I have a u squared over here, u into u squared, and on the second term I have a u squared. And then I have sin theta over here. As well I have a sin theta over here. It's nothing but sin squared theta actually, but we'll see what happens to that. And then I take out the g cos square phi as common. I'm taking out the g cos square phi as common. Okay, since there is a cos square phi over here, I will take out as g cos square phi as common. This g, when it comes to g square, which has become to the power 1. When I am taking out g cos square phi as common, then this term inside the bracket would become u cos theta, because cos theta is left over, and this would become cos phi, because basically I am multiplying it with cos phi on the numerator and denominator to get this. Minus of sin theta into sin phi. Simple, guys. Now what we need to do? We need to understand this mathematical form of it. So it is cos theta into cos phi minus of sin theta into sin phi. What does this tell you, guys? It is in the form of cos of A into cos of B minus sin of A into sin of B. That would give me cos of A plus B. That is what we have done over here. It's 2u squared sin theta by g cos square phi into cos of theta plus cos of phi. And one more thing, guys. You can find out the maximum range. In this case, if someone tells you 45 degrees, no, it's not 45 degrees. Okay? It's not 45 degrees. What you need to do is, you need to differentiate it. You need to differentiate this range to find out that, phi and theta for which the range becomes maximum. Okay? And if you simply differentiate it, and you will find out that range max is equal to u squared by g into 1 plus sin phi pi, which would basically come in the form of theta is equal to something like pi by 4 minus pi by 2. But just maybe in this entire thing, you may want to remember this, because differentiation would take a lot of time in this particular case. So the range max for an object projected up the plane would be u square by g into 1 plus sin phi. Really simple, guys. Now we will talk about the other case of projectile motion in inclined plane or on an inclined plane from the top. If I am projecting the object from the top, what is going to happen? Think about yourself standing on the top of the hill and then projecting the ball. What is going to happen? What is going to happen differently from projecting it from the bottom? Something phenomenal is happening. Someone is pulling you down. Something is pulling you down. Some force is pulling you down. That is nothing but gravity. So this time, the gravity is accelerating the motion along x-axis direction. The same resolving components, everything is going to be the same. Everything is going to be the same. The only small difference would be along x-axis direction, that the gravity is going to accelerate. The E component along the x-axis direction is going to accelerate the motion along x-axis direction. Okay? Now, what would you do? You know something that along, like x-axis direction, it is going to be plus g sin phi. That is going to be the only difference. Plus g sin phi is going to be the only difference. Minus g cos phi will remain same, where phi is the inclination of the inclined plane or the slope of the inclined plane. What are the angle of the inclined plane? So now we'll do the same thing for time of flight. We'll do the same thing for time of flight. Just like a diagram where I've just not just kept it on the inclined plane, rather rotated it to look like on a plain paper, and nothing is shown different, just the difference is plus g sin phi. It's along plus x-axis direction and along the u cos theta. And for time of flight, I'm going to do the same thing, guys. Same thing. I'm worried about those points where it is going to come down and touch that inclined plane. Go up and come down and touch that inclined plane. So same thing, you make use of Vy is equal to Uy plus At, and you will get that the time of flight is equal to 2u sin theta by g cos phi. And what about maximum height? Same thing. Vy squared is equal to uy squared plus 2ay into h max. And in this case, you would simply do the same thing and you would get the answer as u squared sin square theta by 2g cos phi. H max is nothing but this height, isn't it? This height along, perpendicular to the plane. Okay. What about range now? Range, same equation, but plus g sine phi as the acceleration. Same equation, but plus g sine phi as the acceleration. So it's going to be Sx is equal to ux plus half at square. Again, you would say range is equal to u cos theta into total time of flight, plus of half of g sine phi t square, where t is time of flight. Again, you substitute the time of flight values. Okay, and now you would notice something, little bit different, but maybe like some expression around it. This would be the common, you'd get the common the same way that we got earlier. It's going to be 2u squared into sine theta by g cos square phi. And that would be cos theta into cos phi inside the brackets plus of sine theta into sine phi. What is this? This is in the form of cos A into cos B plus cos sine A into sine B, which is nothing but sine theta minus phi or sine phi minus theta. So the range would be 2u squared sine theta by g cos square phi into cos theta minus phi. But guys, did you notice the difference between the range of one that has been projected at the same angle on the same inclined plane, but from the bottom of the plane up the inclined plane, and the difference between the object projected from the top of the inclined plane down the inclined plane at the same angle and same velocity? What is the difference? The difference is the range. Okay, because up the inclined plane, the x-axis component or the x-axis velocity is being drained by the resolved component of gravitation, whereas down the inclined plane you would see that it is accelerating the motion. That means it will also cover more range. Okay guys, and the difference is this small term. There it was, up the inclined plane it was cos theta minus phi, down the inclined plane it is cos theta minus phi, which also gives you that print. As then when theta goes, like this entire term inside cos, let's call it something like alpha keeps going up and up, then what is happening? The value of cos theta becomes less and less. So this tells you this should be theta minus phi. Okay, just a small intuition. And what about range? Maximum range? So maximum range you would have to again differentiate it, but in this case you would find out it is 1 minus sine phi in the denominator. So it is going to be, the maximum range in this case is u squared by g into 1 minus sine phi. Okay guys, and the difference is 1 minus sine phi, there it was 1 plus sine phi. Why? The max range is also going to be more for the down the inclined plane motion. 1 minus sine phi value is going to be lesser than, probably lesser than, if not 0, then you'd get it as u squared by g, which is the normal thing. But if not 0, then it is going to be less than 1, which means range is going to be greater. Whereas there it is going to be 1 plus sine phi, u squared by g into 1 plus sine phi, where it is going to be lesser, because 1 plus sine phi means it is going to be greater than 1. Alright guys, very easy. Inclined plane motion was also very easy. Inclined plane projectile motion was also very easy. Let's do something very interesting, We have understood all the concepts. So what are the concepts that we covered? Projectile motion on a level plane, the ideal projectile motion from a height, just with the horizontal velocity, projectile motion from a height, with and horizontal and vertical velocity, just like an ideal projectile motion. Then projectile motion on an inclined plane, up the plane, and projectile motion on an inclined plane, down the plane. Okay, we covered different variations of projectile motion. I told you in the single lecture we will be covering everything. We will be covering the bits and pieces of projectile motion. Now we will do something interesting, that is solve few problems around this inclined plane problem, like a conceptual problem, and then we'll get into an IIT JEE problem, a latest IIT JEE problem. Okay guys, so there are two objects A and B projected at same angle from the same inclined plane with same initial velocity, where A is projected down the inclined plane and B is projected up the inclined plane. You already know the answers guys, keep typing it, keep writing it down. So there are two objects A and B which are projected at the same angle from the same inclined plane with same initial velocity, where A is projected down the inclined plane and B is projected up the inclined plane. Then which of the following is true? Okay, A and B will have same range, time of flight and h max. You know this is not correct. You know this is not correct because down the inclined plane gravity is accelerating the x-axis direction motion, and A and B will have different ranges, time of flight and h max, which is also not correct because they are going to have same time of flight. And what about C? B will have more range than A will have, D is saying A will have more range than B. B will have more range than A, or A will have more range than B. Which is correct? Students, come on. Which one is correct? The one that is projected down the inclined plane will have more range. Okay? This concept should be very clear. The one that is projected down the inclined plane should have more range. So it is going to be D. A will have more range than that of B when projected at same angle on the same inclined plane but on the opposite ends. That is one up the inclined plane, one down the inclined plane. Okay guys, now let's do something interesting. That would be a JEE Advanced or a JEE IIT JEE 2011 problem. Just like what we did before, very similar, just little bit different. Little bit means little bit different. So the question says a ball of mass 0.2 kg is at rest on a vertical height of 5 meters. Okay, there is a ball that is at 5 meters, and then there is a bullet of mass 0.01 kg, very like light bullet, traveling with some velocity. I'm guessing it's a high velocity. Okay, in horizontal direction only, and hits the ball. And after the collision, what is happening is ball and the bullet travel independently, and they both hit the ground at a distance of 20 meters and the bullet at a distance of 100 meters. So the ball is hitting at 20 meters and the bullet is traveling until 100 meters. Then the initial velocity of bullet is. Should we do something different now? It's basically a problem that we saw earlier. So in a short sentence, there is a ball at rest and it is hit by a bullet traveling at some velocity, and this ball is reaching 20 meters from the foot of the post, which means 20 meters range, and the bullet has traveled 100 meters range. So there is a collision happening over here and we have been given the range. So we need to calculate the velocity, the initial velocity of the ball to find out the initial velocity of the bullet. So that's the first step. But can we do it even without, touching the pen and paper? Is it possible? Quite possible, I guess. You just take v squared is equal to u squared plus 2as, where u is 0 for the ball, and you will have to calculate for both bullet and ball. Initially, we'll do it for ball. So for ball, the v is like r is what we know, the range is what we know. Okay, we know the acceleration. We need to find out the final velocity. Okay, and then we would work it out for the bullet the same way. Okay, so find, like, the range of the ball is 20 meters, the height of projectile is 5 meters. The time of flight is under root 2gh, which is nothing but v squared is equal to u squared plus 2as. It's not the correct one, guys. I'm correcting myself. It should be v squared is equal to s is equal to ut plus half at square should be the equation. Okay, s is equal to ut plus half at square should be the equation. So you would make use of s is equal to ut plus half at square as the equation to solve this problem, and then you would get the answer of time of flight, and using the time of flight you can substitute in the range and you would get the initial velocity of the ball. So let's do it without this. Okay, let's do it in a very simpler way. So the total vertical displacement is 5 meters for the ball. Now the weight of the ball is given to us, which is irrelevant to calculate the initial velocity or the initial velocity of the ball. Okay, and we know the initial velocity along y direction is 0 because the collision is in the x-axis direction. Okay, so what would I do? I would make use of the equation s is equal to ut plus half at square, and s is 5 meters along y-axis. It's minus g. Okay, but that is also minus 5, so that minus would go off. 5 is equal to half into 10. Okay, in this case you are going to take it as 10. If the 10 does not work out, if you want to work out with 9.8, try not doing that. If you want to work out with 9.8, well and good. If you work with 10, look for the nearest value in the options. Okay, so it is going to be 5 is equal to half into g into t square. G is 10, 5 is the displacement, so it's going to be 10 divided by 10. Isn't it, guys? It's 10 divided by 10. But 10 is the gravitational acceleration and 5 is the, like the total vertical displacement. And you would get time of flight as 1 second. What about the bullet? The time of flight is going to be, you are going to calculate it the same way. Okay, but in this case you know the range. You can do it even using the range, I guess, but yeah, let's do it using the height. So 5 meters, again you know that you will be able to calculate the time of flight and you will be able to calculate the velocities, the initial velocities after the collisions, and then make use of the conservation of momentum and find out the initial velocity. So now we know that it's again going to be under root 2hg, again 1 second, but the difference between the bullet and the ball is that the ball has covered a lesser of a range, that is 20 meters, where 20 is equal to u. U is just velocity, u of ball is nothing but just the velocity along x-axis direction into time of flight, which is 1 second. That means the initial velocity after collision of the ball is 20 meters per second. Whereas for the bullet, it is going to be 100 meters into 1 second. Okay, 100 meters is equal to 1 second into initial velocity, which is going to be 100 meters per second. And apply the conservation of momentum. You initially know that the bullet was traveling with v meters per second, and that should be v into 0.01 kgs is equal to the mass of the ball is given as 0.2 kgs. So that is going to be 0.2 into 20. That is going to be 4 plus 0.01 into 100. That's going to be 1. So total 5. 0.02 into 20. The initial velocity of the ball after collision. The initial velocity of the bullet after collision is 100 meters per second. 100 into 0.01 is equal to 1. So 4 plus 1 is equal to 5. Okay. We know that the final momentum is 5 and it should be conserved, which should be equal to 0.01 into v. 0.01 into v. 0.01 is the mass of the bullet. And you take the 0.01, the other side, you would get that v is equal to 500. But anyway, we'll have a look at the steps. So two things given to us: height of projection, from which we can find out the time of flight, and the range of the ball, which is 20 meters. Okay, height of projection completely determines the time of flight, and the range determines the horizontal velocity or the velocity after collision. So that would give me u of ball is equal to 20 meters per second. Just how we did it, while speaking. And the range of bullet is 100 meter. The height of projection is 5 meters. That is going to determine the time of flight, which is going to be 1 second. And using that 1 second, you know that the velocity of the bullet should have been after collision 100 meters per second. And now you will conserve the momentum. You'd say mass of ball into mass of bullet after collision is same as the mass of bullet into the velocity of the bullet before collision. So So that would be 0.01 into velocity, that is v. Don't confuse this v while writing down the equation. This is the v given to us. Okay. 0.01 into 20 plus 0.01 into 100, that would be 4 plus 1, 5. 5 would be the momentum, kg meters per second. And 0.01 is the mass of the bullet. That would yield that initial velocity of the bullet is 500 meters per second. Okay. So the initial velocity of the bullet is 500 meters per second. See, I took the G as 10, but I got the answer. If it was given like 9.8, just find the nearest answer. It must vary by 0.2. You can do that thing as well, but this also is something that you can do. Alright guys, I think this session was awesome. We covered pretty much every concepts, pretty much like IIT problems, pretty much like, what can be expected and what kind of things can be expected. Before that, we'll cover, before ending the session, we'll cover some concepts in, like inclined plane projectile motion, understand some concepts. So I think this is not inclined plane concept problem, this is a normal problem. When the projectile is at its highest point of trajectory, okay, when the projectile is at the highest point of trajectory, the direction of velocity and acceleration are, come on guys, this is very easy. This is also an IIT question. This is actually an IIT question. This is not inclined plane problem question, this is an IIT question. And it was asked that when the projectile is at the highest point of its trajectory, the direction of velocity and acceleration are, at the highest point of the trajectory, they are perpendicular to each other. Don't you remember, like along y-axis everything was strained. So along y-axis only gravity is the acceleration or the deceleration, and all the velocities along x-axis. So the top, it was perpendicular to each other. Okay, at the top it was perpendicular to each other. And let's look at like a practical concept. How would projectile motion look when you are projecting it under the real life conditions? So in real life conditions, there is something known as air viscosity. You must have studied it in fluid mechanics. If not, I'll tell you what is air viscosity. This air around us is creating some sort of mechanical viscosity or kinematic viscosity, whatever you call it. It is sort of the friction in the air. Not exactly the friction. Friction is different, viscosity is different. Just an analogy, like a friction in the air. So this is sort of decelerating the motion in any direction actually. That's the issue. This particular kind of viscosity. So what would happen is the object projected in projectile motion, an ideal projectile motion, would cover more range and more height, whereas projected under air viscosity under normal conditions would not cover so much of a range and height. Just the concept around when you project an object in air viscosity or normal conditions, the situation is going to be a little different. And finally, I'll talk about the same strategy again, resolve the components in x and y direction, be it even for different reference plane, apply the sign convention, practice the sign convention, apply the sign convention, practice resolving components in x and y direction, identify the relevant Newton's equation of motion. That is more important. You know the knowns. For the unknowns, you should be able to determine that Newton's equation of motion. Even if there are two equations from which you have to derive, you should be first identifying those and set in your mind that the problem in projectile motion is easy. It will become really easy. Nothing is difficult, guys. Keep learning, keep watching, subscribe to the channel, click on the bell notification, like the video, share it with your friends, share the knowledge, don't just keep it to yourself. Kill the ego, guys, kill the ego, value your time, value love, keep smiling and do not gossip at this time especially. Success is something you have to work hard. Success is something that comes from, your 99% of perspiration. You have to work hard. Keep acquiring knowledge and keep sharing, guys. Share our channel, like the video, talk about people about this channel and enjoy it, guys. And myself and Unacademy have something interesting for you. That's our Unacademy learning app where you can attend some free live special classes with our top-notch educators. And guys, if you are preparing for a test and if you're looking for some test series or live quizzes or interaction with top-notch educators and doubt clearing sessions with top-notch educators, you can get our subscription. And if you're looking for IIT JEE, you may choose this specific program for IIT JEE and you can apply my coupon to get a 10% instant discount. Enjoy, guys, enjoy your life, enjoy physics, enjoy projectile motion, stay safe, enjoy everything, keep smiling, stay safe, guys. Bye-bye.